Okay, today we are starting with the miscellaneous questions of integration. Starting with the first question, we are supposed to integrate 1 plus 2 tan square x. We know that integration of tan square x, we can use the identity 1 plus tan square x equals to sec square x. So tan square x is going to be sec square x minus 1. And we know the differentiation of tan x used to be, if y was tan x, dy by dx would be sec square x. That means when you're going to integrate sec square x, you will get tan x. Okay, so this is in our knowledge already, so we can substitute tan square x by sec square x minus 1. So let's do that. Integrating 1 plus 2, in place of tan square x I'm writing sec square x minus 1 dot dx, and the boundaries which I have to use is pi by 3 and pi by 6. Okay, when I'm going to start integrating, the integration of, first let's simplify this. 1 plus 2 sec square x minus 2 dot dx, which is a 2 sec square x minus 1 dot dx. So we're supposed to integrate now. Pi by 3 and pi by 6 are the boundaries. Okay, so let's start with the integration process. The integration of tan square x is sec square x is tan x, so 2 tan x minus the integration of 1 is x. Now I have to apply the boundaries of pi by 3 and pi by 6 on this. 2 tan of pi by 3 minus pi by 3, this is the first bracket, minus 2 tan of pi by 6 minus pi by 6. Okay, tan of pi by 3 is root 3 minus pi by 3. Minus 2 times tan of pi by 6 is 1 upon root 3 minus pi by 6. Let's simplify this. Okay, it's 2 root 3 minus 2 upon root 3 minus pi by 3 plus pi by 6. Okay, well, how have they written the answer? That's what you always have to look. Okay, they've simplified this part, taking out the LCM and this part separately. So if I solve this, it's under root 3. So this will be 6 minus 2 minus, if I solve this, it will be 2 pi plus pi. 4 root 3 minus pi by 6 is the answer. So you just have to prove that it is equals to this. So we're done with the first question. Moving on to the second one. Find the exact value of, and you have to integrate this, giving your answer in the form. Okay, let's integrate this. Integration of 4 upon 1 minus 2x minus 2x. The boundaries are minus 2 and minus 4. Now we see that here we have to use ln. Now the differentiation of this is just revising. If it is 1 upon x, we write the integration of 1 upon x is going to be ln x. Okay, because whenever you see that the differential of this or the derivative of this is up in the numerator, you will write it as this ln x. If it is, for instance, 1 upon 2x plus 3 and we have to integrate this, the differentiation of this whole thing is 2, which is not here, so we're going to include 2 here. You're going to multiply it by 2 here on our own, and to cancel the effect of this I can write 1 upon 2, so the result will be 1 upon 2 ln 2x plus 3 dot plus c. Okay, likewise, if it is 1 minus 2x, the differential of this is minus 2. Okay, so what I'm going to do right now is that I'm going to separate them first. 4 1 minus 2x dot dx minus 2x dot dx. Both you have to put the same boundary, minus 2 and minus 4. Okay, now I'm taking this 4 as common. Okay, this is going out. You're left with this. Okay, my differentiation of 2x is, sorry, integration of 2x is 2x square upon 2 when you simplified and put the boundaries, which are minus 2 and minus 4 in the next step. Okay, here in order to integrate this, we know that the integral is negative 2, which is not here. So if I need a negative 2 here, so if I need a negative 2 here, I will put a negative 2 here as well, just to if cancel the effect, this can be cancelled out with this, because this we have introduced on our own, so we are introducing this as well. So now the result of integration will be minus 2 ln 1 minus 2x with the same boundaries, minus 4 and minus 2 and minus 4, minus x squared with the same boundaries, minus 2 and minus 4. Now since they have the same boundaries, I can just put it in one bracket also. Let's put it like this way: minus 2 ln 9 minus 2x minus x squared, okay, with minus 2 and minus 4. Let's plug in minus 2 as the value of x. Minus 2 into minus 2 is a plus 4, minus 2 square is 4. This is the first bracket, minus. Now I'm going to plug in minus 4 in place of x in this whole thing. So minus 2 ln 1 minus 2 into minus 4 is plus 8, minus 4 square is 16. Okay, let's simplify this. Minus 2 ln 5 minus 4 plus 2 ln 9 plus 16. Okay, so I'm writing 2 ln 9 minus 2 ln 5 plus 12. Okay, so if I take out 2 as common, I'll be left with ln 9 minus ln 5 plus 12. 2, I can apply the quotient law here because they have the same base, which is e, so you can divide them, plus 12. Now this 2 is going to become the power, 9 upon 5 the whole square plus 12. It's 81 upon 25 plus 12. This is the final answer to this question. Okay, you have to give the answer in this formula, a constant and ln this upon this. You can even write 12 in the beginning as they have written. They've written the constant first, so we can write down the constant first. This is the final answer. Okay, moving on to question number 4. Find the exact value of this. I'm going to integrate this whole thing. Integration of cos we know is sine of 3x divided by 3, and integration of sine is negative cos, so plus cos 2x upon 2. Okay, we've already integrated, so I have to put the boundaries of pi by 6 and a 0 here. Okay, I'm putting the values now. Sine of 3 pi by 6 upon 3 plus cos of 2 pi by 6 upon 2 minus sine of 0 is 0 only, 0 upon 3 is 0, plus cos of 0 is 1, so 1 upon 2. Okay, let's simplify this. It's sine of, okay, 3 gets simplified with this, and sine of pi by 2. Sine of pi by 2 is sine of 90, which is 1 upon 3, plus this is cos of pi by 3. Cos of 60 degrees is half. Half divided by 2 is actually 1 upon 4 minus 1 upon 2. Let's simplify this. Okay, so I'm taking out the LCM together. Okay, LCM is going to be 12, 3 4 times, 4 3 times. 1 upon 12 is the final answer to this question. Moving on to this question, you're supposed to integrate this and you have to show that this result is going to be equal to this. Let's do it. We have to integrate this. First we are going to simplify 3ex minus 2 the whole square. I can apply the formula a minus b the whole square is a square minus 2ab plus b square. Okay, so it will be 3ex to the power 2 minus 2 into 3ex into 2 plus 2 the whole square. Okay, let's simplify this. It will become 9 e to the power. Now a power inside the bracket and a power outside the bracket gets multiplied, so it will be 2x minus 6 into 2 is 12 ex plus 4. Okay, now I have to integrate this with the boundaries 1 and 0. Okay, let's start with this. Okay, if I have to integrate e, whatever is the power of e, for instance 2x, write it as it is. If this is y, Okay, and if I have to integrate this, in case of integration, we write down the power as it is. We differentiate the power and write it in the denominator. Okay, so you differentiate the power always, and after differentiation, whatever is the result of the differentiation goes in the denominator. The differential of 2x is 2, so we'll write 2x here and we divide it by 2. Minus 12e, the differential of x is 1, so we divide it by 1, plus 4x. Boundaries of 1 and 0. Okay, it's 9 upon 2 e to the power 2. I'm starting to plug in 1 in place of every x now. Minus 12 e to the power 1 plus 4. This is the first bracket. Minus 9 upon 2 e to the power 0. E to the power 0 is actually 1, so I'm writing it 9 upon 2 only. Minus 12 e to the power 0, which is 1, plus 0. 4 into x is 0 only. Okay, let's simplify this. It's 9 upon 2 e2 minus 12e plus 4 minus 9 upon 12 plus 12. 16 minus 9 upon 12. 23 upon 2. Okay, so it's 9 upon 2 e square minus 12e plus 23 upon 2. This is what we had to prove. Okay, moving on to this one. You're supposed to integrate it. Okay, and find the integral of this where k is a positive constant. Okay, let's integrate this first. 5e minus 2x divided by minus 2 plus 2e minus 3x divided by minus 3. Okay, and we have to put the boundaries of k and 0. Okay, this will become minus 5 upon t e to the power minus 2k minus 2 upon 3 e to the power minus 3k. This is the first bracket minus, and if x is a 0, this whole thing will become 0. Anything to the power 0 is 1 only, so it will be minus 5 upon 2 minus 2 upon 3. Once again, e to the power 0 is 1. Okay, let's solve it. Minus okay, I can take out the LCM, which is 6. 2 3 times 3 into minus 5 is minus 15, e to the power minus 2k minus 3. 2 times 2 into 2 is 4, e to the power minus 3k. Okay, let's solve this also. Minus 19 e to the power. Okay, the final answer which we will be getting here, we can take out 1 upon 6 as common, since 1 upon 6 is in the denominator overall, so I can take out 1 upon 6 as common. I'll be left with minus 15 e to the power minus 2k minus 4 e to the power minus 3k, and this was minus 19, so it's plus 19, so plus 19. Okay, this is the final answer. Moving on to this question, you're supposed to integrate this 3 upon 5 x plus 1. Now the same procedure, I want a 5 up in the numerator, because the differential of this should be up in the denominator, so that you can apply ln. Now 5 is not there, so I'm taking out this as common. I'm taking out 3 as common. 1 upon 5x plus 1. 5x plus 1. I want a 5 up in the numerator, so I'm multiplying this by 5. So I'm dividing it by 5, so that the effect can be cancelled. Okay, dot dx. So the integral of this is going to be 3 upon 5 ln 5x plus 1. Okay, now you have to apply the boundaries. So I'm taking out 3 upon 5 as constant, and I'm applying the boundaries of 4 and 2. 3 upon 5 ln 5 into 4 is 20 plus 1 is 21 minus ln 5 into 2 is 10 plus 1 is 11. It's 3 upon 5 ln 21 upon 11. This is the final answer, and this is what he had to prove. Okay. Find the value of the constant a such that 8x upon 2x plus 5. Whenever you notice that the degree of x is the same in the numerator as well as the denominator, we have to go for long division. So I'm doing long division here. 2x plus 5 here and 8x here. Okay, 2x goes 4 times into 8x. Change the sign and you're done with it. Now you multiply. Once you're done with this, you have to multiply 5 by this 4. So 5 into 4 is a 20. Okay, when you change the sign, and then the remainder is minus 20. So it's going to be the same as 4 plus negative 20 upon 2x plus 5. If you compare it with this, a is actually negative 20. This is what we had to find out in the first part. So we're done with the first part. Hence, show that the integral of this is equals to this. Now, instead of integrating this, we will integrate this now. So it is equivalent to this. That's why. And the b part, the integral of 4 dot dx plus negative 20 upon 2x plus 5 dot dx we have to do. You have to find this out. Okay, integral of 4 is going to be 4x. Okay, I'm taking out 20 as common first of all because I need a 2 up here. So I'm shifting this 20 first outside. I'm left with 1 upon 2x plus 5. I need a 2 here, so I'm multiplying it by 2 here. Okay, so the result of integration of this is going to be, next step, 4x minus 10 ln 2x plus 5. Okay, and now I have to apply the boundaries of 3 and 1 on the whole thing. 4 into 3 is 12 minus 10 ln 2 into 3 is 6 plus 5 is 11. This is the first bracket. Minus 4 into 1 is 4 minus 10 ln 2 plus 5 is 7. Okay, let's simplify this. Okay, 12 minus, I'm writing all the constants together, 12 minus 4. Okay, plus 10 ln 7 minus 10 ln 11. Okay, 12 minus 4 is 8 plus, if I take out 10 is common, I'll be left with ln 7 upon 11. Okay, so 8 plus 10 ln 7 upon 11 is the final answer. Okay, if you write it this way, that's also acceptable, but since they've written it in a different way, let me explain it to you. Okay, if I want to put a negative sign here, 8 minus 10, in that case I have to write 11 upon 7. So either ways it's correct, but since they've asked us to write it like this, we can write it like this. Okay, moving on to the next question. Show that sine square x cos square x is equals to 3 upon 2 minus upon 1 minus cos of 4x. Okay, we know the identity here. Uh, we can, since they've written all in terms of cos x. Okay. Okay, let's do it. It's 12 sine square x cos square x equals to, okay, if I just change it in terms of cos square x, what will I get? Sine square x is 1 minus cos square x into cos square x. I'm going to get 12 cos square x into 1 minus cos square x. If I multiply, I get 12 cos square x minus 12 cos 4x. Now, with the identity, I know that cos of 2x equals to 2 cos square x minus 1. So, if I make cos square x a subject, it will be 1 plus cos of 2x divided by 2. Okay. And if I make if I square both the sides, okay, because I need cos square x also and cos 4x also. If I square both the sides, okay, so if I make it into cos 4x, I have to square this side as well, which is 1 plus cos 2x upon squaring of 2 is 4. When I apply the formula 1 plus 2 cos 2x plus cos square 2x upon 4, which is equal to 1 plus 2 cos 2x. Now cos square 2x, I'm taking it from here. Here we have cos x. If I make it into 2, I will have to make it into 4. If I'm writing doubling the angle, you have to double the angle here as well. So I'm writing, in place of cos square 2x, I'm writing 1 plus cos of 4x divided by 2, and this whole thing was divided by 4. Okay, so I can write 4 here. Okay, this is equivalent to 1 upon 4 plus 1 upon 2 cos of 2x plus 1 plus cos of 4x divided by 8. So overall 8, instead of writing overall 8, I'm dividing this by 8 and dividing this by 8. So what I'm going to do right now is, in place of cos square x, I'm writing this. So I'm writing it separately, half plus half cos 2x. 12 into half plus half cos of 2x. Okay, minus 12 into, I have to write down this whole thing now. 1 upon 4 plus 1 upon 2 cos 2x plus 1 upon 8 plus cos 4x upon 8. Okay. Okay. Let's simplify this now. Okay, this will become 6 plus 6 cos 2x minus 3 minus 6 cos 2x. Okay, minus 3 upon 2 minus 3 upon 2 cos of 4x. This is what I have already. I'm going to just take the constants into consideration. 6, 3 and negative 3 upon 2. 6 minus 3 is 3. 3 minus 3 upon 2 is 3 upon 2 only. So I'm writing 3 upon 2 here. Okay, if I take cos 2x and minus 6 cos 2x will cancel out. You're leaving, we are left with minus 3 upon 2 cos 4x minus, if I take out 3 upon 2 as common, I'll be left with 1 minus cos of 4x. This is what I had to prove. Hence show that integration of this is going to be equal to this. So instead of integrating this, I can integrate this because this is equivalent to this. Okay, so second part. Second part, I'm just doing it again. I'm copying the question again down here. Okay, hence show this. In place of this thing, I'm writing this whole thing. So 3 upon 2 minus 3 upon 2 cos of 4x. Integration of this dot dx. And the boundaries are pi by 3 and pi by 4. Okay, let's integrate this. 3 upon 2x minus 3 upon 2. Integration of cos is sine 4x divided by 4. So I'm multiplying it by 4 here. Okay, now I have to apply the boundaries on this. Pi by 3 and pi by 4. Okay, 3 upon 2 pi by 3 minus 3 upon 8 sine of 4 pi by 3. Sine 4 pi by 3 minus 3 upon 2 pi by 4 minus 3 upon 8 sine of 4 pi by 4. Okay, it will become 3 upon 6 pi. 3 and 3 will cancel out. You're left with pi by 2 here. Pi by 2 minus 3 upon 8 sine of 4 pi by 3. Okay, minus 3 upon 8 pi minus 3 upon 8 sine of pi. Sine of pi is 0, so this whole thing has become 0. Pi by 2 minus 3 upon 8 pi. I'm simplifying it. हेलो. हाँ बोलो. हाँ. नहीं जाओ. नहीं 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 नहीं. हाँ 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 शायद. आई एम नॉट श्योर. मुझे नाम याद नहीं है ना उसका. मेरे ख्याल में नौरीन नहीं है नाम. नहीं नौरीन नहीं. हाँ नौरीन नहीं. नहीं नहीं बिल्कुल भी नहीं है. नहीं. Okay. Pi by 2 minus 3 upon 8 pi. I have to solve. Okay, so I'm solving this. Pi by 2 minus 3 upon 8 pi. It's 1 upon 8 pi, so pi by 8 here. Minus sine of 4 pi by 3. Minus 3 upon 8. Sine of 4 pi by 3 I'm solving. It's minus 3 upon 2. Minus root 3 upon 2. Okay, this will become pi by 8 plus 3 root 3 upon 16. So this is proved. Okay. So we're done with this. This question. Okay, we're supposed to integrate this now. So I'm multiplying the bracket. This will become 4 into 3 is 12 ex plus 4e 4ex times e2x. This will, you have to add the powers, so it will become x plus 2x, which is 4e3x. Okay, dot dx. So I'm supposed to integrate this. This will become 12ex upon 1 plus 4e3x divided by 3. Okay, so this is the answer. Okay, show that the next question. This is done. The next part. Okay, show that the integration of this is going to be this, the b part. Integration of 3 plus 2 tan square theta dot d theta. Okay, so pi by 4 here and negative pi by 4. Okay, this will become 3 theta plus, first of all let me simplify this. This will become 3 plus 2, 1 plus tan square theta equals to sec square theta. So 1 tan square theta is equal to sec square theta minus 1. Theta plus, okay, let me simplify this first and then 3 plus 2 sec square theta minus 2. 2 sec square theta plus 1. Okay, let's simplify. Let's integrate this 2 tan square theta, so it will be 2 tan theta. The integration of sec square is tan. 2 tan theta plus theta. Okay, now I have to apply the boundaries of pi by 4 and negative pi by 4. We know tan of pi by 4 is 1, so 2 into 1 plus pi by 4 minus tan of negative pi by 4 is negative 1 obviously. So 2 into negative 1 minus pi by 4. Okay, 2 plus pi by 4 plus 2 plus pi by 4. So okay, if I take out 1 upon, they have taken half as common. Okay, let me just simplify it first. 4 plus pi by 4 plus pi by 4 is pi by 2. If I take out half as common, I'll be left with 8 plus pi. Okay, let's see if I'm getting the same result as this. Half into 4, 8 is 4, and half into pi is half pi. Okay, so that's correct. This is the answer. Okay, this brings us to the end of the video. Thank you so much for watching it.